welcome to SWAM's online lecture series on the topic Database Management System. I am Mohammad La Bukhari, working as a professor in the Department of Computer Science at Aligarh Muslim University, Aligarh. Today we are going into some key concepts that will unlock the secrets of database design, including data definition in a structured query language, view, and queries in a structured query language. Get ready to simplify complex ideas and supercharge your database skill with me. In the previous session, we have discussed the introduction part, in which we have gone through a structured query language, data definition language, data query language, data manipulation language, data control language, transaction control. Before proceeding with today's agenda, I would like to discuss some questions that I had given you in the last class. The first question was, explain a structured query process in detail. SQL is a language used to communicate with the relational database. The SQL process typically involves several steps. The first step, querying. User write SQL queries to retrieve, insert, update, or delete data from the database. Parsing. The database system parses the structured query language query to check its syntax or structure. Optimization. The system then optimizes the query execution plan to minimize resource usage and maximize efficiency. Execution. The optimized query plan is executed and the requested operation is performed on the database. Result retrievals. If applicable, the system retrieves the results of the query and presents them to the user. Overall, SQL simplifies interacting with databases by providing a standardized language for performing various operations on the database. The next question was, describe some key features of SQL. SQL is a powerful tool for managing relational databases, offering a range of key features essential for data management. One of its primary functions is data retrieval, allowing users to extract specific information from databases using commands like select. Additionally, SQL facilitates data manipulation through commands such as insert, update, and delete, enabling users to add, modify, or remove the data from the tables. Moreover, a structured query language provides extensive data information. SQL provides extensive data definition capabilities with commands like create, alter, and drop, allowing user to define and modify database schema structures. Beyond that, SQL supports the data control by managing user performance, by managing user permissions and access level, ensuring the security and the privacy of database contents. What are the basic data types supported in SQL? SQL supports various basic data types essential for storing and manipulating data with relational databases. These data types include integer, decimal float, character string. SQL supports storing character data using data types such as char, varchar. Char stores fixed length string, while varchar stores variable length string. Date and time. SQL provides data types of representing date and time values, including date time stamp, and interval. Boolean. Some SQL implementations support Boolean data types for storing true, false, yes, no values. Binary data. SQL allows storing binary data such as image or files using data types like blob, binary large object, and clob, character large object. Explain difference between SQL and NoSQL in detail. The answer is SQL and NoSQL are two different types of databases that have different strengths and weaknesses. SQL databases are relational, which means that they store data in tables with row and columns. NoSQL databases are non-relational, which means that they can store data in a variety of formats such as documents, key value pairs, or graphs. SQL databases are good for storing structured data such as customer data or financial data. They are also good for complex queries such as finding all customers who live in a certain city and have made more than $1,000 in purchases. NoSQL databases are good for storing unstructured data such as social media posts or sensor data. They are also good for scaling to large amount of data. So let let's start the agenda of today's lecture. As today we will going to discuss data definition in a structure queue language, view in a structure queue language, and the last is queries in a structure queue language. Data definition language or DDL serve as the architect of our database world, enabling us to shape and mold the various structures that hold our data. Let us delve into the world of DDL, where commands and syntax combine to create and modify the foundational elements of our databases. DDL commands are the blueprint of our database universe, allowing us to create and modify a variety of objects with predefined commands and a specific syntax. These objects include table, sequences, locations, aliases, schemas, and indexes, but DDL is more than just a set of commands. It's a standardized language that empower us to define storage groups, structures, and objects within our databases. With DDL statement, we can create, modify, and remove database objects such as table, indexes, and storage groups. DDL are fundamental tools for shaping the structure of databases. DDL allows us to create, modify, and delete database objects such as table, indexes, and database themselves. For instance, there are the following commands available in data definition language. The first is create table, next alter table, drop table, create index, drop index, create database, drop databases. With commands like create table, we can define the structure of our table, specifying column names and data types. Alter table enable us to make a changes to existing tables, which drop table allow us to remove them entirely. Similarly, the command like create index and drop index will optimize database performance by creating and removing indexes. Additionally, DDL commands such as create database and drop database allow us to manage entire databases within our database management system. Understanding DDL empowers us to design and maintain databases tailored to our specific needs. Views often described as a virtual table offer a powerful way to organize and present data within a database. Let us take a closer look at views and their role in database management system. A view is essentially a virtual table whose content are defined by a query. Similar to a regular table, a view consists of name, columns, and rows of data. However, unlike a table, a view does not store data values directly in the database. Moreover, views can be used as a security mechanism, providing a layer of abstraction between users and the underlying database tables. By granting users access to data through views without directly exposing the base tables, database administrators can control access and ensure data security. Let us take one example. Let's say we have a database with a table name employee containing a column of employee ID, name, and department. We can create a view called department that display only the employee ID and the name of employee in the HR department. In this example, demonstrate how view can be used to simplify data access, customize perspectives, and provide security mechanisms in database management system. So now we will go. So now we will going to see the types of views, which includes the following: index views, partition views, system views. Let us explain one by one. Index views. Index views optimize query performance by pre-computing and storing results, enhancing data retrieval speeds for frequently accessed data. Partition view. Partition view organize large data sets into manageable partitions, improving data management and query performance by working with the subset of data. The last is system views. System views provide metadata about the database, its objects, and configuration setting, offering value offering valuable insights for monitoring and troubleshooting purposes. Let us, under, Let us understand what is index view. Imagine you have a database of sales transaction with a million of records. An index view could be created to calculate the total sales amount for each product category. This view would pre-compute and store these totals, making it faster to retrieve sales data when querying by product category. For example, if you want to find the total sale amount for the electronic category, instead of calculating it each time from scratch, the index view would already have its information readily available. Readily available. Let's say you have database of customer information, but the data is so large that managing it become challenging. With partition views, you can divide this data into a smaller. With partition views, you can divide this data into a smaller, more manageable sections based on the specific criteria such as a geographical region. For instance, you can could create For instance, you could create partition views for customers in different countries. This way, when query customer data, you can focus on a specific region's information without having to deal with the entire dataset, which improves both the data management and query performance. Next is system views. Consider you are a database administrator responsible for monitoring the health and performance of your data. System views provide essential metadata about the database, such as information on the tables, indexes, users, and system configuration settings. For example, you can query system views to check the status of database backups, view the current connections to the database, or monitor the growth of the database file. This information helps us ensure the database runs smoothly and troubleshoot any issues that arises. Structure query structure SQL queries serve as a backbone of interactions with relational databases, enabling user to perform a wide range of operations. Let's divide into some command Let's divide into some common types of SQL queries and explore their functionalities. So we have the following queries in SQL. First is select queries, insert queries, update queries, delete queries, join queries. The select queries is perhaps the most fundamental structured query statement used to retrieve data from one or more tables. With the select statement, user can specify columns, conditions, and storing criteria to extract specific information from the database. Next, we have the insert query, which allows user to add new records to the table. By providing values for each column, user can seamlessly insert a new data into the database, expanding its content. Moving on the update query, users to modify existing records in a table by specifying the columns to update and the new values, user can easily make changes to the data stored in the database. Similarly, the next is delete query, allows user to remove records from a table by specifying conditions. User can selectively delete unwanted data, ensuring database. Lastly, we have the join query, which is used to combine data from multiple tables based on the related columns. By linking tables together, user can retrieve comprehensive data sets that provide valuable insights. Let's see some additional SQL queries that expand our capabilities in managing or analyzing data within relational databases. First, we have the group by query, a powerful tool for aggregating data. The group by statement allows us to group row based on the values in a specified column. It's often paired with aggregate for aggregating data. The group by statement allows us to group row based on the values in a specified column. It's often paired with aggregate functions like count, sum, average, and more, enabling us to summarize and analyze data at higher level. Next, we encounter the order by query, which enhances result set organization. The order by statement stores the result set based on one or more columns, providing users with the ability to control the presentation of data and ensure meaningful insights. Lastly, let's explore the concept of subqueries. also known as nested queries. A subquery is a query embedded within another query, allowing us to retrieve data that will be used by the main query. Subqueries are incredible versatile and can be employed in various scenarios to enhance the data retrieval and analysis. These additional structure queries, these additional SQL queries expand our toolkit for manipulating and understanding data within relational databases. Whether aggregating data, storing results, and leveraging nested queries, structured query language empowers users to unlock deeper insights and make informed decisions. So, as we discussed today, data definition in SQL, views and queries in SQL. Now, here are a few simple questions for a home assignment based on the above lectures. These questions aim to reinforce these questions aim to reinforce the key concept covered in the lecture. The first question is, what is the purpose of group by statement in SQL and how is it typically used? Explain the role of the order by statement in sorting query results. Provide an example to illustrate this usage. Define what a subquery is in SQL and describe the scenario where it might be useful. How does the group by statement differ from order by statement in SQL? Provide examples to highlight their distinctions. The last question is, discuss the importance of participating SQL queries in gaining proficiency and database management. How can you apply the concept learned in this lecture to real world scenarios? Thank you for joining today's lecture on SQL queries. I hope you found the session insightful and gained a deeper understanding of how SQL queries can be used to manage and analyze data efficiently. Remember, practice is the key to mastering these concepts, so don't hesitate to experiment with structured query language queries in your own database projects. If you have any questions or need further classification, feel free to reach out. Thank you.